What we're going to talk about here is another fundamental rule which we can use when it comes to differentiation. This is called the quotient rule. Now, whilst the product rule looked at two functions multiplied together, this one, as the word quotient would suggest, looks at two functions where they divide one another, so the ratio of one another. But it takes a set format just like the product rule did. Now, let's think along the same lines as the product rule. We've got two functions, both of them are differentiable, but in this case, they divide one another. This is where we can use this rule called the quotient rule. So let's imagine we've got an overall function called y of x in the format of f of x over g of x. What we can do is to take the derivative, we use the quotient rule, and that tells me that y dashed of x equals f dashed of x times g of x minus f of x times g dashed of x all over g of x squared. Now this is actually fairly straightforward to prove. If we imagine we take the y of x equal to f of x over g of x, we can actually write this as a product of two functions by bringing the g of x up and changing its index to a negative value. So we end up with f of x times g of x all to the negative 1. And now that we've got this, we can use the product rule. So what the product rule tells me is I'm able to do f dashed of x times g of x to the negative 1 plus f of x times the derivative, so let's say d by dx, of this g of x to the negative 1. So I've got all of that. Now this part here, what I'm going to do is I'm going to change that to f dashed x over g of x. Let's get rid of the negative power to begin with. And this bit here, I'm going to look at calculating d by dx. Now in order to do that, I can use the chain rule. So to calculate d by dx of g of x to the negative 1, what I can end up getting is I get negative 1 times g of x all to the negative 2. That's then times g dashed of x. So using the chain rule, that gives me that format there. So this second term, if I put all this back in and turn this into a positive in this again, that's then going to be minus f of x times g dashed of x all over g of x squared. So what I can now do is combine these and put them over a common denominator. So if I times the top here by g of x and the bottom by g of x to get g of x squared, what that then gives me is f dashed of x times g of x, take away f of x times g dashed of x, all over g of x, all squared. So there you go. That's me showing that it works like that. Now, a key thing I want you to remember is this top line has to take this format. So it's always derivative of the top times the bottom, take away the top times the derivative of the bottom. We always have to follow that through and make sure it takes that format. Otherwise, the signs will get muddled up and we actually won't end up with the same answer that we're looking for. Let me show you an example or two of how to do this. So let's imagine I want to find d by dx of x cubed over sine x. Now similarly to the product rule, the first thing we want to do is assign our f and our g, then calculate the derivatives, and then stick it all in the formula. So I'm going to always label the top, the x cubed, as the f, and I'm going to label the bottom, the sine x, as the g. I'm then going to calculate f dashed and g dashed from that. So my derivative of f dashed is 3x squared, and my derivative of g dashed, is given by cos x. So what I can then say is therefore d by dx of the x cubed over sine x, we know that that's going to take the form of the quotient rule, so I'm going to have f dash g take away g dashed f all over the g squared, and now it's just plugging the information in. So f dash g, that gives me 3x squared times sine x. That's then going to be take away g dash f, so x cubed times cos x. And that's then all going to be over the g squared, which is sine x. So that's then all going to be over sine squared x. Now at this stage, if you can simplify it, do it. I could take out a common factor of x squared from both terms on the top if I wanted to, but I'm happy enough just to leave it into this format. Sometimes you'll be able to cancel out, and if you can, do it. Get rid of as much as you can and just make it as simple as possible for you when you're working with it. Second example, one that I'm going to do for you, is finding the derivative of tan x. Now, it's easy enough for me to say what's the derivative of tan x and you remembering it, but we have to be able to show it. Now, tan, we know, is given by sine over cos. So we know that tan x is sine x over cos x. And what this means is I'm able to use the quotient rule to find the derivative. This is how they proved that they'd found the correct version of the derivative of tan x. So again, what I'm going to do is I'm going to label the top f, the bottom g, and follow through the same steps. So my f dash, derivative of the top, is going to be given by cos x. My g dash, the derivative of the bottom, is going to be minus sine x. So what I'm then going to do is plug it all into the formula and see what I get. So the derivative, d by dx of tan x, is going to be given by f dash g, so cos x, times the cos x on the bottom, so cos squared x, take away g dashed f, so it's going to be minus sine x times sine x, so that's going to be minus sine squared x, all over g squared, so all over cos squared x. Now this bit here on the top, minus minus becomes a plus, so that gives me cos squared x plus sine squared x. And at this stage of your mathematical career, I'd hope by now you remember that cos squared plus sine squared is equal to 1. So what that then gives me is 1 over cos squared x. Now 1 over cos is sec x. Look at the special trig functions video. So what that means is that it's sec squared x. So what we're then able to say is that the derivative d by dx of tan x is equal to sec squared x. There you go. So that's me got it done. So the quotient rule has lots of applications, even back to functions from trigonometry that we did when we first started looking at it back in S1. We can start to apply it to slightly more complex functions and build it in. Now one thing to remember is we may even have a product rule within a quotient rule. So our top line or our bottom line may take that format for when we're calculating the derivative. So just bear in mind that we can combine these together. We can do a combination of rules and work them through all together.